In this video, we're going to talk about kinetic energy. Kinetic energy is defined as the energy of an object in motion, and it is measured in joules. The equation for kinetic energy is given as E sub k is equal to 1/2 mv squared, where m is the mass of the object in kilos and v is the speed of the object in meters per second. So as you can see, mass is a scalar and speed is a scalar, so kinetic energy is also a scalar value. If we take this formula here, the EK, and let's say we multiply the numerator and denominator by m, we can have m squared v squared over m. And then if we rearrange this a little bit, we get 1/2 mv squared over m. And we know that momentum is given as mass times velocity. And so here we could say that the kinetic energy is also p squared, which is momentum squared, over 2m. So this is an alternative form to the equation 1/2 mv squared for the kinetic energy of an object. Let's do some examples. So an object has mass m and speed v and kinetic energy e. A second object has half the mass and moves at twice the speed. What is the kinetic energy of the second object in terms of e? And so when we're structuring these questions, we can do it trying to think it through. So we know that if mass is half, that means the kinetic energy is half because mass and kinetic energy are proportional. And if we know that if the velocity is double, then we can do 2 squared, so it's times 4. So ultimately, at the end, it's 1/2 times 4, which ends up being 2. So this object would have twice the kinetic energy of the original object. Another way to think about this is algebraically, sometimes we can lay these out if we get a little bit confused. So we know that E is equal to 1/2 mv squared. So that's the original E, the original amount of energy. And then what I can do is I can create a new variable. Sometimes I call it like E2 or something like that. And I know it's going to be equal to 1/2. And now I'm going to have half the mass. And I'm going to have 2 times the speed squared. And so this ends up being 1/2 times 1/2 m times 4 v squared. And I'm going to remove this 4, and you'll see why I'm writing it this way. So I'm going to remove this 4 out here. So now I have 4 over 2 times 1/2 mv squared. And so that leaves me with 2 times 1/2 mv squared. And the reason I wrote it like that is because originally I would define 1/2 mv squared as E. So I can replace this part of the equation here with E, and that leaves me to 2E. So the answer is C. 1,200 kilo car slows from 25 meters per second to 15 meters per second. Calculate the change in kinetic energy. So whenever you calculate the change of something, the change in kinetic energy is going to be the kinetic energy in the final minus the kinetic energy initial. And so in this case, it's going to be 1/2 times 1,200 times 15 squared minus 1/2 times 1,200 times 25 squared. And if I plug this in my calculator, I get negative 240,000 joules. I wanted to highlight this question here because we have a negative value. But I said earlier in the video that kinetic energy is a scalar. And so what we have to recognize is this negative doesn't indicate a direction as it would for things like acceleration and velocity. A negative in terms of energy, this represents a loss of energy. And so as the car was slowing down, going from 25 to 15, it was losing energy. Typically that's brakes, so you're losing energy to like thermal or friction or air resistance, all of those things. And so I just wanted to clearly illustrate to you that a negative energy doesn't mean the direction. Negative energy refers to a loss of energy. Now we have a 0.5 kilo ball is launched at 22 meters per second at an angle 35 above the horizontal. Calculate the kinetic energy at the highest point of its motion. And we're going to ignore air resistance in this case. So if we have an object that's launched at an angle and it flies through, it's going to take a parabolic path. It's a projectile. And they're asking us to calculate the kinetic energy at the top. And what we know about projectile motion is that at the top, The vertical velocity in this case is 0. So the object doesn't have any vertical velocity, so it wouldn't have any kinetic energy vertically. However, it does have a horizontal velocity, and we know for projectile motion, horizontal velocity is constant throughout. So the horizontal velocity for a constant with no air resistance stays constant here. So we have to take the initial velocity at 22 meters per second, 35 degrees, and figure out what the horizontal velocity is, and then that will be the horizontal speed that we can use in our kinetic energy equation. So if we have it going initially 22 meters per second at an angle of 35 degrees, our horizontal velocity is going to be 22 cosine 35. So our horizontal velocity is going to be 22 cosine 35, 18.0 meters per second. So this is the velocity horizontally at the top of the motion. And so the kinetic energy at the top is going to be 1/2 times 0.5 kgs times 18.0 meters per second, all squared. Gives us a value of 81 joules. So that's the kinetic energy at the top of the flight. In summary, all moving objects have kinetic energy. Kinetic energy is proportional to mass, and it's proportional to the speed squared. It's a scalar value, and is measured in joules. And then, very key idea here in this video is negative kinetic energy represents an object losing energy.